Hello, let's do the New York Times Hard Sudoku for December 12th, 2023. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, we have these two sevens looking into this box. That does place, ooh, that's not the button I wanted. That does place a 7 right there. Two ones looking into this box. What's a 1 somewhere up here? Let's see. Sixes. This 6 and this 6 look in. So 6 is in one of these two. This does what's called pointing. So in pointing, it's when you have these corner marks. So I guess I should explain what the corner marks mean. Within this box, where does 6 go? Well, the answer is one of these two cells only. And so we use corner marks to designate, or to remind ourselves that within the box, that is where that digit can go. It has a bunch of uses, but one use is pointing. If they line up in a row or column, then that means that they have to use up that row or column, that digit for that row or column. So these can't be 6. Otherwise, if you think about it, if I put a 6 here, there'd be nowhere to put 6 in this box. And the box needs a 6. So you can think of it as these line up and they point at the rest of the row and eliminate that digit from the rest of the row. So these can't be 6. This 6 looks in, this 6 looks up. And 6 can be only in one of these two cells. So we know that the 1 and 6 are going to end up here somewhere. Let's see. 4s are interesting, I think. Yeah, so 4 is left to just these two places. 3 as well. Okay, so 3 and 4, we can corner mark them separately. But actually, what this is telling us is that within this box, 3 is in one of these two cells, and 4 is in one of these two cells, and nowhere else. So they kind of overlap. So, if I put a 3 here, the 4 ends up here. If I put a 3 here, the 4 ends up here, right? So if I put a 3 here, this has to be 4. If I put a 3 here, this has to be 4. And those are the only two options. So this will always end up as a 3 or 4 in both cells and nothing else. It kind of crowds out anything else those cells could have been. That's called a hidden pair. All right, so we know this can't be 1 or 6. We know this is down to at most 2 digits. I think it's going to be 2 digits. Can't be 1, 2, 3, 4. It could be 5 and 9, it looks like. So there we go. We can mark that. And these are 1, 5, 6, 9. Yeah, I'm not really seeing anything special about that. Okay, so what else can we do up here? We got the 7s, 1, 3, 3s. We already kind of did 3s. Okay, let's go on to the next band here. So we have 2 2s here. This 2 looks down, but that doesn't actually matter because there's a 4 in that spot. So 2's in one of these two. 8s. 8s are nice. So 8 looks in, this 8 looks in. And this 3, 4 are not 8. So 8 is in one of these two. And that, again, is going to point. So that points down. I mean, it technically points up as well, but there's already an 8 in the box, right? So the 8s point down. This 8 looks down. Putting an 8 in one of these 3. And what we're doing is we're trying to remind ourselves that these can't be 8 anymore. Because I don't really want to center mark them at this point. They have way too many options. But we need to remember that 8 is not actually an option for these two. And that's what the corner marks try to help with. Oh, 1s are very nice in this box here. These ones look in, so 1 goes there only. So now what we want to do, because this is full, just like this one, we want to look for digits that aren't already in the box. So like the 8, for example, ends up in one of these two. And that does also point down, putting an 8 in one of those two. We also have the 7. 7's in all three of one of these 3. But it does mean also that the 7's in one of these two. And here we do. Here we found another hidden pair. So that's a 7-8 hidden pair because of our overlapping corner marks. Anything else? Well, this is a 7-8 pair. There's only 2 digits that are kind of unaccounted for, the 3 and the 5. So we can just put a 3-5 pair here. That's what's left for the column. So this is a triple. 2, 2, 6, 9. We know this one's not 6, so let's just fill that out. 2, 6, 9. Oh, it's not 2 or 6. I somehow didn't scan that right. So that's where the 9 goes. This is a 2, 6 pair. Now that we know this is a 2, 6 pair, we know this can't be, it already couldn't be 6, but it can't be 2. So in these 4 cells, we need to put 3, 4, 5, and 9. This is not 3, so this is 4, 5, 9. Oops, I meant to center mark that. Unfortunately, I don't really see anything to do with that immediately, so let's just move on. So we were looking at this band and actually ended up doing this stack because of this getting filled up. We got some good stuff out of that. Let's think about the 4 that are left in this box because it might be helpful. So we need a 2, 3, 5, and 9. Well, we know the 9 is here. 2, 3, 5, 9. That's all we're really going to get out of that. All right. Anything else to find over here? Excuse me. Okay, these two ones look in. So one's in one of these two. I was looking at 4 in this column because we had this 4 and this 4, but it's not quite enough. The column needs 4, 5, 6, and 9. Ooh, this sees 4, 6, and 9, so this is a naked 5. This sees 6 and 9, so this is a naked 4 now because it can't be 5. That gives us the 3 and the 4, the 5 and the 3. This is not a 4. And then the remaining digits, 6 and 9, they can place. We can place the 6 and the 9, so that 9. So this column just finishes if you look at it. You sneeze on it and it collapses. All right. A little wisp of wind. 2, 5, 8, 9. Okay, 8 in this box, right? These two 8s look in. So 8's in one of those two. I somehow missed that in my initial scan, but that's all right. We need 2, 5, 9 here. I'm just going to fill that, 2, 5, 9. We know the 2's in here somewhere. Okay, what can I do with... I should look at basically the blue digits, right? The ones that I just got. So, oh, how about this 9 looking over? So there's a 9 there. Are 9s... I thought 9s would be close to done, but... Okay, so these 9s look into here, right? So there's a 9 in one of these two cells. And then... I think that's all we're getting from 9s. All right, so this 6 and this 6 look into this box, putting a 6 in one of these two. This cell's avoiding a lot of the corner marks. Let's think about it. Because it can't be 6, 7, or 8. So it's down to, at most, 3 digits, but I also see it sees a 4. So it can't be 1, 2. It could be 3. It can't be 4. It could be 5. It can't be 6, 7, 8, or 9. So down to 3, 5 only. How about these 3 cells? These are 2, 3, and 5. That's suspicious, but can't do anything with it yet. What else did we get? This 8 looks down into here, so 8's in one of these, for what it's worth. 7 looks into here, so 7's in one of these two. Okay, did I? Okay, I haven't really scanned fully yet. We have all these 6s looking into this box. So 6 is in one of these two. The 9s, the 5s, the 7s. Okay. I feel like there should be something I can do vertically here. I'm going to just think about what digits are needed here. 3, 4, 5, 7, 9. 3, 4, 5, 7, 9. Yeah, there's not much except a 7 to think about. This can't be 7 or 9, or 4. So this is 3, 5 only. This is not 3 or 7. So 4, 5, 9. Not really at that point right now where I need to be penciling random cells, but it feels like there ought to be something to find, but I guess there's not. Okay, so we did vertically here. Let's look here. We do have 4s looking in. So 4 in one of those two. All these 4s looking in. 2 3s look down. So there's a 3 in one of these two. I think that's all we get. And over here, we pretty much already looked at. Okay. So now we need to look for restricted cells. Unless there's some geometry I missed. 1, 2, 8. We do need a 1 in one of these two. I missed that. 2 can be up here. Otherwise, it would be forced down here. That's kind of interesting. Okay, this cell's avoiding the 3, 4, 6, 8. Okay, well, how about this row? What does this row need? It needs 2, 3, 7, 8. This is not 2 or 3, so this is 7, 8. And that makes a 7, 8 pair, so we're left with 2, 3 here. This can't be an 8 anymore. This can't be a 3, so we get the 2 and the 3. We get the 5. This is not 2, so we get the 2 and the 8. This is not 8, so we get this 8. This is not 5. Now down here, I did see that this made a 1-8 hidden pair, so we will mark that. And then this is now a pair, 2 and 4. Okay, so the 2-4 does look up. This is not a 2. That puts the 2 here. All right, this 5-9 and this 5-9 are the same digit. This is 1-6-5-9. It's the other 5-9, this one. Okay, anyway. So 2-4 pair, 5-9 pair. This is a pair as well. Involves a 7. 3 and 7. So we know the order. That's a 7, that's a 3. So that 3 there. This is not 7. This is a 5. 2 digits left in this row. We need 3 and 7 again. So this is 7. This is 3. These are not 3s, which puts a 3 here. This is 2 or deep. This is not 2, so it has to be 6. Because we need 2 and 6 in this column. This is not 9. Can it be? Okay, so 7 in this box is here, and then this is 4. This is 9. That's 9 and 1. This is a 5. Looks like we're collapsing. That's not a 1. That's not a 3. Okay, so let's fill digits. This digit is a 4. This digit is a 5. What are these? 1, 6, 9. So the 9 goes there, the 1 goes there, the 6 goes there. That's not a 6, so the 6 goes there. We still can't place the 8, though. Let's just fill these. We need a 3 in this column that can only go here, and then we need a 5. That gets us the 2 and the 5, the 4 and the 2. Gives us this 4. This is an 8 and a 7, 1 and 8, 8, 7, and we're left with a 1. And there we go. All right, pretty straightforward today, actually. Some good hidden pairs that probably helped, like this 7, 8 here. I don't remember what the hidden pair we got first was. I'm sorry. I try to recap these, but sometimes I don't remember. I definitely remember this 7, 8 hidden, which seemed really useful. We ended up with a 1, 8 hidden here near the end of the solve, which was fun. But yeah, nothing super crazy going on here. Let me know how you did. And of course, if you enjoyed this, then why not leave a like, subscribe, and a kind comment below.